Okay, Brandon, here's what I did. I think it's what you'd like it to do. I can't save the file right now. I think the GeoGebra website's down, but I think this video will explain it, and I should have something for you tomorrow. Maybe I can send a link to you. So the first thing I did is I created this. It looks like it turns into a slider, but actually it's just where I can set my sample size. So I just click in there and I can change it. Oh, quick, let me undo that. If I click in it, I can change my sample size to whatever I'd like it to be. So I can change it to 10 if I want. This next thing, this is a set, this list called ages. And I use the sequence command, which creates a list for me. This list has 692 objects in it, and they're all random integers between 5 and 30. I had to do this thing in Desmos for 500 normal numbers, from a normal distribution, and sometimes you may just need to type all of them into the spreadsheet individually. It just may take a while, but that's what you may have to do. If you have them existing somewhere else in another spreadsheet, you can copy and paste them. But so this gave me all of my fake coin ages. Then there's a command here, this next line. This is a command called it's a set called ransamp, but the command is sample. And it's going to take a random sample from the ages set, which is right above, and the sample size is right now set to 10. This false number means do you want it with replacement or without replacement? When it's false, it's without replacement, which is what you want, because they're not going to take the coins out and put them back in. Let me skip this end slider. If I go to A, that's computing the mean of this random sample. And then the data is my empty data set, and the length is so you know how many elements are in the data set. And this L1 is the dot plot. Data true, I'll show you what that means in a second. My slider is an integer slider. And right now it goes from 1 to 100 in steps of 1, but it really doesn't matter. It could go from 1 to 10 if you wanted to. It really doesn't matter. What matters is the magic in the scripting. So if I go to the settings, this is the settings for the slider, and if I go to the scripting tab, you should recognize these commands. So instead of clicking a button to do this, I'm going to drag a slider to do this. And every time I drag the slider, the update construction is going to re-randomize everything, and I'm going to take the mean of that random sample and stick it in that data set. So right now I've already gotten 3 elements in there. And so what you can do is you can click on it, and then I'm using my arrow keys on my keyboard just to go back and forth. Or I could use the play button, and let me speed it up a little bit. And every time that slider moves to another value, it's re-randomizing all these samples at the top, and it's computing the mean, and it's sticking the mean into the data set. So right now I've got almost 80 data values. And let me go ahead and pause that. Let me direct your attention down here to the dot plot command where it says data true. The true tells the dot plot to stack values that are close to each other. So to show you what I mean, if I made this to false, see how the dot plot works now? It looks kind of ugly. I really don't care for that a whole lot. And it kind of hides the central limit theorem I think that you're trying to get at. So if I turn this to true, what this does is it stacks kind of adjacent values. It almost puts it in a bin, if you would. So if I were to change the size of my scale, you can see some of these dots will kind of stack up with each other. If you want to change the sample size, click reset first. That clears out everything, and then you can change your sample size. So if I want to change my sample size to, say, 50, which is an okay sample size because it's less than 10% of my population. And let's go ahead and press play. And I should get a dot plot that is well, less variable than the last one. And hopefully it's centered somewhere around the mean age of the population, which looks somewhere around 18. Actually, that kind of makes sense. I bet if you took 35, like added those two, well, 35 and add them together, or like from 5 to 30, half of 35 is around 18, so that seems to be where maybe the mean ages would be. So anyway, that's that, Brandon. And then again, I'll be on that Zoom webinar tomorrow in the morning. So if you have any other questions, you can ask me then. And I'll see if I can save this document and get it to you. But if not, I think you can follow this video and recreate it.